Now we're going to start looking at a second method for solving triangles because as great as law of sines is, there are some situations where it doesn't work, and we're going to look at two of those examples today. The law of cosines formula is on your reference sheet, and I have it shown here as well. If you actually look at the reference sheet, I have two versions of it on there. One of them is the same formula, but it's been solved for the cosine A, cosine B, or cosine C part to make it easier to find the missing angle if that's what you need. So if you're looking for one of the sides, use this form. If you're looking for one of the angles, I would direct you to look at your reference sheet and use the other form that has cosine of A, cosine of B, or cosine of C by itself. One note, after solving for one of the missing values using law of cosines, you can usually use law of sines to find the rest of the values on there. There are some situations where you might just want to keep using law of cosines while you're at it anyways though, and then law of cosines does not have an ambiguous case, which is one of the nice things about it. I reviewed a couple geometry properties in the last section, but there's one more I wanted to tell you guys or remind you of, and that's that the sum of the two smaller sides has to be bigger than the largest side. So there will be some cases where the question might ask you, is this a triangle? That's something that you might want to check first. Can you add up the two smaller sides, and will they end up being bigger than the largest side? So for example, if you are given sides of 1, 2, and 13, well, the two smaller sides are not going to add up to be bigger than the 13, so it can't make a triangle no matter how you try. So let's look at one of the examples where law of sines does not work. The problem with this SAS setup is that you don't have any of the pairs of values. We don't have both angle and side A, or both angle and side B, or both angle and side C. So no matter how you try to set up the law of sines, your relationship is going to have two variables in it, and you're not going to be able to solve for either one. So in these situations, we are going to end up using law of cosines instead. Now, the order that you do these things in really doesn't matter. If you want, I would probably start off by solving for the missing side. We don't have side C, so we can just plug the values into this formula right here, because we do know side A, we do know side B, same things here and here, and then we do know angle C. So if I'm plugging into this formula, I'm going to have C squared equals 11 squared plus 5 squared minus 2 times 11 times 5 times cosine of 20 degrees. So you can see that this formula is set up that we'll be able to figure out what c squared equals just by computing everything on the other side of the equation in this case. Have your calculator handy, make sure you're in degree mode for the cosine of 20 degrees part, and then just start simplifying this. So 11 squared is 121, plus we have the 25 there. We can go ahead and evaluate this as well. Remember, the order of multiplication doesn't matter, so it might be easier for you to recognize 2 times 5 is 10, and then 10 times 11 is 110. And then in this next piece, we can say 121 plus 25 is 146. And this is where I'm going to actually have to switch to using the calculator now. So 146 minus 110 cosine of 20 is giving me an ugly decimal, and again, be very careful about this decimal value because you don't want to just round off what it equals. I'm just writing down so that you can make sure you plug this in correctly in your own calculators. What you are actually going to want to do is take the square root of both sides of the equation. So in your calculator, you'll want to find a way to hit square root of the previous answer in your calculator. That way you're not rounding off some of the decimal places. So then I'm getting C is approximately equal to 6.5. The directions do say round to the nearest tenth. So now we have all three sides of our triangle. Now, like I said, you could keep using law of cosines and take advantage of the formulas I have on the reference sheet for you guys to find the missing angles, or a lot of you might find it easier to switch to using law of sines at this point. So I'm going to set up sine of 20 degrees over side C, which we found is 6.5, and we'll set that equal to sine of b over 5 for the b side. We're going to cross multiply this, so 5 times sine of 20 equals 6.5 sine of b. And then in your calculator, you can just go ahead and enter 5 times sine of 20 and divide that by 6.5. Now again, don't just round off this decimal. I'm just writing it out so that you can make sure you're getting the right numbers in your own calculators. What I actually want to do is hit sine inverse in my calculator. That's how we solve for the missing angle. So since I have sine of b equal this number, I'm going to hit second sine to do the sine to the -1 key, and I'm going to enter the previous answer in my calculator so that I'm not actually just typing in 0.2631, and I'm getting that angle B is supposed to be rounded to the nearest degree, so I'm going to say 15 degrees. Now you could use law of sines again to find the third angle, but at this point I think it would be easier for you guys to just recognize we have angle C, we have angle B, so angle A, the capital A, should just be 180 minus the ones we know. So 180 minus 20 is 160, minus 15 more is 145. And that way we have all three angles and all three sides of this problem. Now again, if you would like to just keep using law of cosines, you may. There are some situations where it might be advantageous because depending on what information you were given and what angle or side you found, it could prevent you from ending up with an ambiguous case, since that is one of the complications of law of sines. So just consider whether it'll save you work or if it'll end up creating more work potentially. This is the other situation that law of sines does not work in because again we don't have any of the pairs of values. We only have side A, side B, side C, so I can't cross multiply and get it down to just one variable again. Now this time we are missing the angles only. So the formulas for this, you can use the formula as it's written here and then just solve for cosine of A, that's fine. Or on the reference sheet that I've printed out for you guys, it has it already set up. So cosine of A is isolated, for example, and it says cosine of A equals B squared plus C squared minus A squared all over 2 times B times C. So again, this is something you'll probably just want to use your calculator on. So you would hit 49 plus 25 minus 81, and then you're going to divide that by 70. So that's giving me negative 0.1. And then remember, this is cosine of A equals negative 0.1. So you want to hit cosine to the -1 of that previous answer in your calculator. And then I'm getting A is approximately, rounded to the nearest degree, 96 degrees. I'm going to find a second angle using this same method just so you guys can see how the formula works. And let's also look at where it comes from for a second. If I'm doing the version that's solving for cosine of B, if you were solving for this, you'd just be doing opposite operations. So that's where you're subtracting A squared, you're subtracting C squared, and then you're dividing by negative 2AC. So if you look at the formulas on the reference sheet, that's why you're ending up with a 2AC in the bottom of a fraction, and it's why you're seeing some combination of the A squared, B squared, and C squared being added or subtracted together on the top. Just be careful, the signs might seem backwards from what you expect. That's because when you divide by the negative 2AC, they're just flipping all the signs in the numerator instead of having a negative in the denominator. So the cosine of B formula, we have that it equals A squared, which is 81, plus C squared minus B squared. And this is going to be divided by 2 times A times C. So this time in your calculator, 81 plus 25 minus 49, and divide that by 90. that's approximately equal to 0.63 repeating. But I'm just going to hit second cosine of that previous answer in the calculator, and I'm getting that angle B is 51 degrees. Now that we have two of the angles, there's no real point in going through the formula for law of cosines a third time. We can just do 180 minus 96 minus the 51, since all the angles have to add up to 180, and that way we know that our third angle is going to equal 33 degrees. And so that's all for the notes. Thank you.